Hi, I'm Anna, and today I'm going to chat with you about the tracing crate for Rust. We're going to go through some motivations about where and why you might use it, and go over some examples of use and strategies for when you use it. I'm sorry if some of the examples seem contrived, that's kind of how slides are. Uh, I work for a company called TCDI, and I work on the PGX crate, which allows you to build Postgres extensions in Rust. I live over on Lekwungen territory in Vancouver Island. I also do consulting through my company, Rare Consulting. You're probably here for the crab with the instrument, so I wanted to provide that right up front, and thanks, Heinz, for that. I'm a Rust developer, and you might be too. Certainly, I hope you become one. And while we're working through development all the way through testing and production with our Rust code, we want to have tools to figure out how our system's working and to provide the operators who will be deploying and operating our code with the tools that they need to run it successfully. In many cases, these are projects that are ending up deployed and processing hundreds of thousands of requests per second. So we need to be conscious of how we're designing these systems and making sure that we can observe them in a correct ways, even at that scale. So our solutions that we seek should work not only just on one machine, but on hundreds of machines if need be through, say, a Kubernetes console or something else. That data, we're going to want to collect it. We're going to want to query it, browse, look at different graphs, and try to derive insights from it. And ultimately, we're going to want to store it for different periods of time. This isn't always just for your developers to, open up a search tool and try to figure out, what happened when. It could be for finance audits. It could be for system validation. It could be for doing profiling or optimization. You could have an emergency. Something could catch fire and you could have an unknown state for your system. And in these cases, having good logs and good tracing will help you be able to figure out where your system is and where you're able to take it. When you're first starting out, the basics quickly become quite insufficient. It's frequently the case you start with print line, but that doesn't really offer you a lot of support. It doesn't show you, for example, files or lines. It doesn't show you module paths. You have to set all those yourself. It quickly becomes burdensome, and you're kind of compelled to reach for tooling to provide some of these for you. It also doesn't do anything like logging levels, which the log crate does, and it's a very obvious first choice for users because it offers simple logging levels and a way to output in different formats, such as syslog format. But even at a certain point, that can become insufficient as your organization grows, because your organization is going to scale. They're going to get more services, more machines. They're going to have the desire not only to just query a service, but query services together. They're going to want standardized protocols and formats. They might have any sort of requirement as your organization grows, and it will continue to change and grow. So a good system's a flexible system that doesn't require you to constantly rework it every time you have some minor technology change. So my suggestion is that you use tracing. It's a really good crate, and I think a lot of folks who have used it in production have had good success stories with it. So this is what some tracing code looks like. In particular, this is setting up tracing, and this is a non-trivial setup. So here you can see at the top, we're setting up a format layer and a filter layer, which combined give us something just like the log crate would. So they're setting up this log format layer, and then they're creating a filter which defaults to info level. And then it's registering them inside of the tracing subscriber registry. And that's sort of, whenever I create a log event, it would go through this registry and each of the layers would be able to affect it. You can see we also have a trace error layer, which integrates with eyre and can create these span traces in our errors, which I'll show you later. I think they're quite interesting and quite compelling. Later on in our code, we'd be able to create these spans of context and give them names. So here I'm creating an info level span called critical section, and it's taking a value or a field called host. And I'm able to put the percent sign there, and what it does is it prints the value of host, which is set above. And then I'm able to enter and exit those spans so that if I did a tracing info call between them, I'd actually see this contextual information. Here you can see that. So that's quite compelling because it allows us to attach data to our logs without having to specify it each time. It's quite advantageous too, is that these spans will allow us to stack. But let's talk about the errors first, because I'm really excited about that and want to show you. So here's a terrible example, to be quite honest, where we have a developer who's chosen to just not show you the environment variable that they weren't able to find. So this error message could be improved, of course. We should be showing that variable we were looking for, but let's do it in a bit of a complex way so you can see this example of span traces. So the way we detect this environment variable is through standard env. And if I wanted to attach some span to the error, I would create a span, and then while I'm entered into the span, call this failable. And when it failed, that information would be captured. I could then continue on. So here's what that would look like now that we've created this span holding the environment variable that we're looking at. So you can see the operator knows exactly which environment variable they need to set, or that it was checking, and also why. So tracing gives us a few main things. It gives us spans of information and context that we can set with different log levels and have attached data. It gives us timing information, and it gives us this registry system that allows us to configure various outputs. It also allows us to integrate other libraries into it that could, for example, provide beautiful error messages. So let's take a look at how we use these things. So levels, which you might be familiar with from the log crate, allow you to convey a sense of urgency or connotation around various messages. Certainly an error message is much more likely to be seen by an operator on their Kubernetes or Honeycomb or whatever dashboard than, say, a debug statement, which is generally intended only for the developers. So being able to create these spans and events at different levels allows us to sort of communicate how, not necessarily urgent or how bad something is, but in many cases, systems will only keep around the error messages for more than a few weeks or something like that. So they allow us to convey some extra information. Here's what they look like on my terminal color scheme, and you can see that it's not that big of a deal here on standard out for our console, but consider when I feed this into, say, some collector like Tremor, it suddenly has some more use where it could be used for filtering and for categorization. Spans allow you to communicate a story to your operators, where you can create this stacking informational context. So you can see here we create a debug span and then an info span, and they're different levels. So the debug span will only show up on debug logging level. So you can see that here. When we run with just normal info logging, we don't see this debug span. But when we go and we set the debug log, or say we pass the verbose flag, we do see that. So you might be thinking, these spans are pretty interesting and the trace macros seem fine, but it seems like a lot of boilerplate, a lot of work. The instrument macro is very helpful here. What it does is it automatically creates a span at the start of a function and enters it, and then at the end of the function it drops it. So here you can see I've decorated this open state file function with an instrument call. I've also set the level. Please note, by default, if you don't pass a level, the instrumentation will happen on all logging levels, which could have negative performance impacts if you're in some particularly hot code that was, say, running every transaction. You may want to choose to instrument things such that high cost displays, such as, say, a hash map with hundreds of values, which takes a little while to print out, would not be included on normal info level logs, because that could create some negative performance profiling in production. So this is what this looks like, and you can see it's created the function name as well as the argument and shown us the value. If we have a failable function, as open state file is, it might crash, it might error if, say, the file was not there or it was unable to read it for some reason. This error, we can have the instrument function automatically print out. So you can see here, because we decorated it with error, it's gone and printed out the error for us. I'd caution, if you decorate multiple functions that call each other with this error, you could end up with multiple lines in your logs showing the same error. That can be a bit confusing for people, so be a bit cautious of that. If you need to, you can skip various arguments. This is frequently very useful for the self argument, as you might have quite a complex structure you are instrumenting. In this case, we could have it skip the path variable. You can see here, we do not have our path variable anymore in the tracing span. On the other hand, we could add new fields. So here I'm adding the bonus field as just 1, 2, 3, super boring. If I wanted to, I could just as happily put path.display or any other Rust code. It takes an expression, not a primitive. And you'll see that this bonus is now displayed on our span. So using spans, we can kind of get a better grip on showing intent and completion. So to better communicate this, take a look at this example where we send queries to Postgres from, say, a web application. We detect that the user's authorized. We detect that the query is valid. And then we make the database request. And things happen, and the database responds with garbage, and the application crashes. Whatever. In this case, let's pretend it doesn't find the Postgres client. Doesn't matter. The question is, did the database request get made such that the database responded? Like, did the thing happen? There's no way to know here. So if there was a disaster, and say this was updating someone's bank account with their new paycheck, there would be no way for your operator to know if the request to the database was confirmed, the transaction completed, because it doesn't communicate that. What we want is to be able to communicate that not only was a request made, but a response was received. You can use the tracing empty value to kind of help with this in many ways, as it allows you to populate a field later after creating the span. So here you can see we create a trace span up top, and we make the field just set to empty. And later on, we can go and set that in the handle request function down below, where we build a UUID, and then we take the current span and we record it. And so this kind of gives us tools to create empathy with our operators, because we can actually communicate better ideas to them without spending a lot of time on it. So here's a little bit of an expansion of the idea before, is we use the lazy kind of empty method to assign a field request ID, so that when we get a new request to our web service, we're assigning an ID to it. And that means that we're able to know which request caused each action in our service. This is circling back to the error example before. You can see we create this error subscriber layer, and we can install a crate called eyre, and eyre is able to work with tracing and read the spans. And so this is pretty much a few lines, and it totally changes the way your users experience errors. So here's one of the errors I received while working on a feature in PGX recently. And you can see it says right to me, it wasn't able to map the argument to SQL, and it shows me how it got to running that code. It shows me that it was creating an extern decorated function SQL, and that function was called make animals. It shows me that that was being called from the PGX SQL generator when it got called to SQL, and that it was trying to write to a file called SQL custom types. So it tells me a lot of information here that I didn't need to put in my error message. I guess that kind of speaks to how tracing can be quite flexible for you, and that's quite useful as your organization grows, as you'll want to be flexible with how you produce your outputs. So tracing has pre-made options for things like JSON and open telemetry. I believe there's also a systemd crate, for example. It also has some pre-made styles for you. So in this case, I just added .json on the end of my format subscriber, and I'm getting JSON outputs, and I could send that to, say, Tremor. I could also create my own styles. Here's the pretty style that was created and added to tracing. And it gives you kind of an example of what you could do for yourself if you really wanted, where it creates this very human readable format. And this is actually my preferred format now. Or you could go different and create a compact style. So this, on the latest version of tracing, this is what compact looks like now. And that's quite different than what we just saw, and it speaks to the flexibility of the technology. More than that, though, tracing allows you to hook in with things like OpenTelemetry. So I mentioned earlier that writing to standard out blindly isn't always the best idea. Your organization might use something like Tremor or something like Honeycomb or eyre or whatever, and they might want to collect events that way. And tracing has built-in support for this. So it allows us to kind of escape this ecosystem that we found ourselves in, where you have like specialized vendor agents or libraries in your code base that are only there to ship events off to your observability vendor. And OpenTelemetry kind of lets us reclaim that space and build really good tools around it that all of us can share and enjoy. So here's how you'd plug tracing into OpenTelemetry. This is actually still outputting just a standard out, but it's using OpenTelemetry's format. So you can see we create the OpenTelemetry exporter as we would normally, and we then wrap that in an OpenTelemetry layer for tracing and stick it in our registry. So it could work alongside our existing system and be an optional integration even. And this is what the data it outputs. It's just a whole bunch more stuff than you might be used to. For some more resources about how to use tracing or how you might want to structure your tracing or your events, you can go check out the tracing GitHub or the Rust doc on docs.rs. They also have a Discord that's full of friendly people like myself that could help you out. And I really quite enjoy checking out the OpenTelemetry site to talk about some of the concepts that have been sort of agreed upon as best practices and standards. Luca's website about zero to production Rust also has a great section about observability that I found quite interesting and I think you'd find useful. And another actual crab with an instrument to say goodbye here. And thanks so much. It was great to chat with you about one of my favorite crates. Have a great day, and I hope you enjoy the rest of your TremorCon. My mouse died.